Hello, everyone, and welcome to our webinar, Build Vector Embeddings for Video via Python Notebook and OpenAI CLIP. My name is Matt Brown, and I will be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars. We do multiple per week, demoing data and AI use cases, new tools, and new technologies. I post about these webinars every week, so feel free to connect with me if you want to stay in the loop or share any feedback on our recent sessions, or if you have ideas on future topics. I'd love to hear those ideas too. It's tough to fill out this calendar, but I'd love to hear your ideas. We've got several great new sessions that are coming up over the next few days. You can see we've got a very packed calendar. Monday, fine-tuning your embedding model with SingleStore. Love to see you there. That's going to be a fun session. The day after, Akmal here is going to be doing Apache Spark plus OpenAI for personalized banking services. Should be cool. And then the day after, Wednesday, accelerate MongoDB apps to drive 100x faster analytics and AI. Very, very cool schedule. I'm excited to see all of them. I'll post these links in the chat in just a minute. Or if you can't wait, feel free to take a screenshot or a photo of those QR codes and RSVP. I know it's kind of annoying if you like all of these and want to RSVP. We are working on a button so that you can do just that. It's not quite ready yet, but hopefully within the next, I don't know, a few days, maybe a few weeks, we will have a button so that you can just auto register. Hope to see you there. Let's get back to today's topic. We would love for you to participate in the discussion. There's a Zoom Q&A button at the bottom of your console. You can click that, but it cannot be anonymous. We would love to answer all of the questions we can today. We will email you afterwards if we don't get to your question, but we have to have your name and email address to be able to respond to you. So if you logged in anonymously, feel free to log out, come back in, just include your name and email address, and we look forward to chatting with you during today's discussion. We would also love for you to try out today's technology that we are going to be showing. In fact, anyone who tries it today will be entered for a raffle chance to win either new AirPods Pro or Meta's new Ray-Ban LLM glasses. It's very easy to participate. All you need to do is log into that link or visit that QR code on your screen. If you have a SingleStore account already, awesome. Just log in and we will add you to the raffle list. If you don't have an account yet, it's very easy. We have a free shared tier at SingleStore, so you can just sign up for free, play around with it, check things out. And by doing so today via this link, you will be added to our raffle list. Let me introduce our speaker. You may recognize him. Akmal is a senior technical evangelist at SingleStore. He has great experience and expertise in big data, machine learning, and AI. He is a prolific author. He's a regular speaker at our weekly webinars on data and AI. I recommend you find him on Medium if you haven't already, because he has an awesome blog. Akmal, the floor is now yours.
Well, thank you very much, Matt. And let me just back here. Okay, just to emphasize this, that we have got, as you can see, a packed program for next week. And although we've covered Spark in the past once or twice, I think we haven't done a dedicated session on it. So I'm kind of working on that one. So that should be very interesting. Not to worry here. I mean, it does say confidential down here. I think we should probably remove that. But other than that, please do sign up for that. And I'll show you where that link takes you in just a moment. Okay, and I'll walk you through the process of creating some resources. So anyway, thank you all very much for attending today. And so good morning, good afternoon, good evening, wherever you are in the world. We know your time is precious, so hopefully this will be useful for you. So just a little bit of an introduction then about the company and the product. Just 2 slides, okay? So this is always useful to show in terms of the history. So it kind of feels everything is 100 miles per hour when you work here. But the company was actually founded in 2011 and used to be called MemSQL. So very much focused around in-memory OLTP applications. Subsequently added support for analytics through columnar storage. And obviously it makes sense then, because you're no longer just in memory, change of name. So hence the name SingleStore. So if we take a look at the numbers, so here you can see in terms of revenue and customers, well, revenue started to see a fairly big spike here between 2017 and 2018. We are now a 100 million annual recurring revenue, ARR company, plus 100 million plus, I should add. And then here you can see in terms of customers, well, we have over 350 global customers. As you can see, many of the names, well-known names down at the bottom there in terms of investors in the company. And between sort of 2019, 2020, about maybe halfway through there is when we again saw a significant increase in the customers. Let me just see if I can highlight that there for you. There we go. That's when the curve really started to go up. And then the other one was sort of around about that time, if I can draw. As far as the technology is concerned, I mentioned the in-memory and the analytics. Well, this is managed through this thing called universal storage, okay? So a single table type that handles both of these types of processing. Now, there may be other vendors out there who are trying to do this as well, but keep in mind that we have the expertise and the strengths and the technology that's been around for some time now. So we've really mastered it, and it is used and deployed in environments around the world. Some of the technologies that we work with, Kafka. Okay, so that's another topic that I'll be covering next week, although Matt was not able to show that on the slide. We are going to talk about Spark next week specifically, and then there's things like Hadoop, HDFS, if you're working with these as well. We can integrate very well with these. And the animation here, as you can see, is really showing this kind of parallel ingest. We have this technology called pipelines, which can do that at scale. And I probably will be using this next week. I haven't quite decided what's the best approach. So we'll see. Okay, for the database as a service, we run on AWS, Google Cloud, and Microsoft Azure. Okay, so the three main clouds in the Western world. We can run on-prem as well. Okay, there's a Docker container as well. So today I'm very much going to be using AWS. Okay, and I'll show you that momentarily. Well, historically, the product has its strength in relational technology. So we do that. And we have demonstrated support for geospatial and time series in the past. There is a full text search engine, okay, Lucene. We can do other things as well. So JSON support has been there for quite some time. It's got even better with the SingleStore Chi for MongoDB compatibility. So if you are using MongoDB and you're looking to do analytics, for example, and looking for speed and scale, then that is a technology that I would highly recommend you look at. And last but not least, excuse me, vectors. Okay, so vector support has actually been in the product for a while, since 2017. Improvements added earlier this year, a dedicated vector type. So previously we had to use blob as the as the data type, but now there is a dedicated vector type, and I'll show you this momentarily as well in the code that we'll look at. And the other thing is that indexing as well. So previously we just did KNN, no indexing. So it's kind of brute force, which is fine for reasonably small scale kind of data sets. But once you scale up, I mean, you want to have something like approximate nearest neighbor, which gives you the ability to really, manage millions and billions of data points and be able to search that very fast. So what you gain is speed and scale. What you lose is accuracy. But the thing is that trade-off may be exactly what you're looking for, and it will allow you to make business decisions a lot faster. And again, you'll see me using the ANN indexing momentarily at small scale. Other things, so real-time decisions, AI apps, dynamic experiences, kind of things you may want to build, dashboards, ad hoc queries, machine learning. I will show you the SQL editor that we have that allows you to run this. Equally, if you want to connect using something like a MySQL CLI client, you can do that. We are both MySQL and MongoDB wire compatible. Okay, so we are wire compatible for both of these technologies. And of course, if you whatever is your favorite dashboard technology, you can connect using JDBC or ODBC. I like using Metabase, the open source version. The free version is just a jar file. You just need Java, and then you can just literally within a couple of minutes, you can be creating charts and visualizations very, very fast. So there we go. Now, machine learning with SingleStore is possible with a variety of technologies. This list is not exhaustive, but you can see some of the technologies, the well-known names here. So as I said before, we'll be looking at Spark in more detail next week. Today, we're going to be very much focused around Python, and I'll be using one of the vector functions in SingleStore for the code that is specific to SingleStore, which is .product. Other things that can help as well is that we have this thing called Code Engine using WebAssembly. So essentially what this does, it allows you to extend the capabilities of the core engine. So you're no longer limited to the data types that it understands. Now you can essentially add your own and add your own logic and business logic, if you like. And that can be done through C++ or Rust. Package these up, upload them into the database engine, and it will treat those as a UDF. And one of the examples that I've demonstrated in the past is this thing here, which is, let me see if I can underline that, called VADA, Valence Aware Dictionary and Sentiment Reasoner, which I've used for sentiment analysis. So that is pretty awesome. And in case you're wondering, this code runs in a separate space, okay? So if there's a bug or some problem and it comes crashing down, it doesn't bring your entire system down, okay? The engine runs in a separate space. And last but not least, I mean, we've got OpenAI as an example, and we do work with other large language models too. Today, we're going to be using OpenAI's CLIP, but we're going to use the open source version, okay? So no API key required, and it's totally free. And if you like, you can actually follow along as well. Okay, so we'll show you that in a moment. So one of the things that we've seen in terms of representational sort of learning is this ability to represent objects with vector embeddings. I'm sure you've come across this. I mean, if you've not heard of OpenAI and LLMs, you've probably been living on a different planet, okay? So this has been the buzz since over a year now. Initially, when this was released, ChatGPT, I kind of ignored it. I didn't think it was very much. It took me a couple of months to start using it. And then eventually when I did start using it, I thought, wow, this is awesome. There's a lot of things that I could use this for to kind of, help me with this kind of work that I do. And indeed, it is very, very helpful. So I see it as a kind of an intelligent advisor, certainly in the kind of work that I do. But then, being able to utilize it for practical business applications, we need a mechanism to represent information in a form that these LLMs understand. And this is where these vector embeddings come in. And so historically, I think we've very much focused around one particular area, and that's text. Naturally, I mean, it's probably the easiest to deal with initially. And so you end up with a way that there is a kind of a step in between here, and then out comes some series of numbers that represent that particular piece of text, okay? But if you think about it, I mean, text only makes up one part of all of the kind of data that we deal with. Think about things like images, for example. Okay, and here's an example here, okay? Just something like this. Or what about if you've got, say, an audio file, something like this? We need representations of these as well, okay? And so now people are much more interested in what's termed as multimodal. So SingleStore is a multi-model database system and data platform, okay? Because it does relational, geospatial, time series, JSON, all of the vectors and all of the things that we looked at. But we have this need now to be able to deal with much more than just textual data. And then there is another issue associated with that, is that if you take a look at this text that we have on the left-hand side, a well-known phrase in Western literature, the quick brown fox jumps over the lazy dog. And then we actually have a picture of the same thing. So if you think about it, these two things are representing the same piece of information, but we are just using a different way. In one case, we're using a visualization. In another case, it's just text. And actually, if we look on the right-hand side, you can see, and these numbers are kind of made up, but I mean, you get the gist of it, okay? That you can see the numbers are quite similar. So what it's trying to get across here is that what we would like to do is to be able to represent this information in a way that is kind of associated, The fact that the text and the picture are close together probably means that they should be placed in some kind of vector space close together as well, to show the fact that they are, represent the same information. As it happens, just below here, the audio probably says the same thing. So you can do things like speech to text, again, using something like Whisper, for example, from OpenAI. But in this particular case, it may say something completely different, because if we look on the right-hand side, we can see that the representation here is very different from the above two. So something to think about there, okay? So this is what our focus is today on CLIP, okay? Because what CLIP allows us to do, it allows us to manage these two things here, this and this, and be able to have a way to say that these sit in the same space if they are very similar in terms of what the text says and what the image represents. Okay, so there we go. And that's all the slides I wanted to show. So I told him that I was going to be very fast today. So I will stop there now and then switch to another tab. Okay, and let's just blow this up a bit here. And let's see, let's make this a bit, what we want to do, we want to zoom in a bit, make this a little bit bigger. There we go. Okay, so the link that Matt shared with you in the chat, if you click on that and sign up, I mean, the link will take you to this page here, as you can see. And so a couple of things here. You can sign up with Google, with Microsoft, or if you want to do it the old-fashioned way, put your name, first name, last name, email address there, and then just click the continue button. On the left-hand side, you can see there's a couple of things that you get as part of this deal. There is the free tier, okay, which I will show you momentarily. If you need something with a bit more sort of dedicated resources and processing, then this $600 credits. Okay, that's the other main thing. And so what I would say there is that I've been with the company over 2.5 years now. So around about the time I joined, I created a free account. And at that time, they used to give away $500 worth of credits. I still have credits today. And so, I've managed that very carefully. So I've shut down resources when I didn't need them. And that credit, the credits still, I think it's still a couple of $100 actually worth of credits available. Okay, so once you've created your account, and I'll ask Matt if he will very kindly share the link, the GitHub link to the notebook that I'm going to use. So if you want to actually try to follow along a bit, although I'm going to walk through it because I've already run it. I talk too much, but you're very welcome to upload it, okay, once I've shown you what to do. So once you've signed in, your environment will look something like this, okay? So again, let's just take a look here. I just want to access the, just zoom in a little bit, make this a little bit bigger there. So you'll see there's a couple of things that you have here. So on the left-hand side, you'll see there's a kind of a left nav. Let me just highlight that over here, okay? So this is where you've got all your controls. And so there's a couple of things that you need to be aware of. We'll look at these in just a moment, but one of these things here, in order to use the notebook environment, you have to have some compute resources already running. And so I'll show you how to do that, okay? So the way to do that is to select this thing here called group. Okay, let me just highlight that. There we go. Okay, so we'll get to that in just a moment. You'll see in the left nav, again, there is a SQL editor. Okay, over here, there we are. You've got notebooks just below here. Okay, and the notebooks allow you to organize into two spaces, either sort of a personal space or there's a shared space. Okay, keep the stuff in the personal space. The shared space, that you have to give permission to other people to be able to, I mean, that's something you can do collaboratively with other people. Okay, that's something to keep in mind. All right. So the first thing we need to do is we need to create some dedicated compute resources in order to use the notebook. So I'll go back up here, okay, to group and just click on this. Okay. So as you can see, it gives you two options here. Here is the free tier. Okay. Some limitations on that, and the limitations are highlighted on the right-hand side, right? So basically, you get a gigabyte of compressed data, one database, 10 tables, and a few other limitations as well. Okay, there's a link there that tells you where to go. Okay, so if you click on that, that will take you to a page that gives you more details. But essentially here, what you can do is if you choose this one, you can change the name of the workspace here. Okay, this thing here. Okay, you can modify that and rename it to whatever you wish. I'll keep the default there, which is just happened to be called Starter Workspace 9, but like I said, you can modify it. At the moment, your only choice of cloud provider is AWS. Okay, sorry, there we are. That may change in the future. And then again, your choice of region is just limited to US East 1, North Virginia right now. Again, that may change in the future. By default, you will get a database created for you as well. So you don't have to actually create any database yourself. It's done for you. And again, you can choose the name. Okay, so here it's given me a database _2485E. It's a shared space. So if you choose a name that somebody else has chosen within this shared space, it won't allow you to create that. Okay, so maybe a good thing to do is like choose your initials, for example, and then you know the database, and then maybe the project that you want to use. So something like this might work. Okay, so AC, my initials, database _clip could be something to do. And then all you need to do is just click this thing here, create it. And if you do that, let me do that for you. Okay, literally in the space of about a second, you get the resources. Okay, so you've got your compute available now. You have your database available. Okay, and you can immediately start using these. Okay. The other method, again, let me just walk that through that with you. If we go back to group, okay, let me select that. And now choosing the standard approach. So if you need a bit more sort of dedicated resources, something with a bit more power maybe, and finer sort of control, then again, same sort of thing. You can choose your workspace group name. Here is your choice of cloud provider, whether it's AWS, GCP, or Azure. And obviously for each of those, your choice of region. So if let me say I'm in London, so probably I should pick something a bit physically closer, like Europe West 2, for example. There's a couple of options here that you may see which are unique to my environment. That's okay. But generally, most of this is the same. And just say next here. Okay. And here you get to choose essentially what you want in terms of the number of CPUs and the amount of RAM. So here, the default size selected is this S00, but you can edit it. Okay, so if I choose this, you can see that you've got more options available here in terms of how many virtual CPUs. If we take a look at S4, for example, that gives us 32 virtual CPUs. 256 gigabytes of RAM, and that will burn through 4.5 credits per hour, okay? So you can see there that that's a bit more expensive in terms of resource, but you know, if that's something you want to use, it's absolutely fine. Okay, so usually an S00 is fine. Now I'll stop there, okay, because I don't actually need this because I have got some of these running. But again, in terms of creating the workspace, you just click on this, and it takes a couple of minutes to provision. Okay, it has to do a bit more work, okay, because it's unique for you, and it has to fire up the resources and do all the back-end stuff for you in order to provision that. Whereas, as you saw with the shared one, literally took a second to provision and have that up and running for you. Okay, so let me just go back. Okay, just go back again. Okay, so we don't need that. And then once you've got some compute resources running, the next thing to do is to upload the notebook, obviously. Okay, so if you select notebooks here from the left nav. Okay, so I'll do that. Okay, and in here you can see that I've got a whole bunch of notebooks I've been working on over a period of time. But if you look in the top right here, there's this big purple button, and it's got this thing that says new notebook with a pull down. And if you select the pull down, you've got two options here. Either you can create a new notebook, or just below it, you can import from file. Okay, and so if you select import from file, it will give you this wizard. So literally, you can just drag the file to this area here. Okay, and then it gives you the option to how you want to organize it. Do you want to keep it in your personal sort of, or you want to put it in the shared space? All right, so let me just browse here. I should have that clip file on my desktop. And here we go. So I'll open this. Now it's going to warn me because it says file already exists in the personal space. So I'm going to select shared. Okay, so that it works successfully. And then all you need to do is just to say import notebook. Okay, there we go. So that will put that into the shared space. Whereas the rest of the stuff is in personal. Okay, so I would highly recommend you put yours in your personal space. Okay, mine is there simply because I've been working on it earlier today. Okay, there we go. So now it's available, and you see at the top here, in your case, you'll see that whatever you've opted for in terms of the compute that you've created, whether it's from the free shared tier or it's something dedicated, you'll definitely see the name of the workspace appearing here. Okay, the database space will be populated for you if you select the free shared tier. It won't be populated if you selected the dedicated one, simply because it gives you more options. Okay, but if you select this, you can see there's a few options there. So you can see this is an environment that I share with my colleagues. So I'll use this one. And I've already got this video DB that I've been using earlier. Okay, so this is kind of dedicated resource, not using the free one. All right, so that's uploaded that. And where does it put that? Well, you can just see on the over here, if you select shared, in my case, for example, if I just blow that up, you see that, again, because this is a shared environment, no pun intended, that there we are, there's my file. clip.ipynb, okay? But actually, the one that I'm going to demo you today is this one here in the personal space, okay? So there we go. So what do we achieve? So you've seen how to create some compute resources, whether you opt for the free shared tier approach, which gives you a database automatically, or if you want to go for something a bit more dedicated, and you know, S00 is perfectly fine. That's the smallest one that you can configure at the moment. I think that just burns through very, very sort of 0.28 credits per hour. And then just make sure, again, that you shut it down when you're not using it. And that will make your credits last a long time. So here is the notebook, okay? And again, let me just make sure we've got this at a slightly larger. So it seems to be already at a larger font, so that's great. All right, so let's just walk through this and see. Let's shade the wrong one. Oh, I'm glad I knew there was a reason why I had this. So the thing is, our notebook environment, it's based on Jupyter, but we provide direct support for Markdown, SQL, and Python. However, because it runs in this kind of Conda environment, you can actually install other stuff as well. So here, what I did, this is R. I've installed an R kernel, and I've done a bit of R programming here. And I've actually written an article about it. So you can see there's some pretty awesome graphics here. I remember now the reason why I had this here, just to show you that, in fact, if you are an R programmer, you can do a bit of R development here, and you can connect to SingleStore as well. So, but it's not directly supported, okay? Basically, you have to install it yourself. All right, so here's the notebook that we're going to work through today. So build vector embeddings for video via Python notebook and OpenAI CLIP. Okay, so hopefully for those of you that are interested and then want to kind of follow along and try and run it yourselves, there's a couple of gotchas. Okay, I'll point those out to you as we go along. Okay, so that you don't get stuck or things become pear-shaped for you. But the first thing to do is basically a couple of libraries here. You can see. So you can see that I executed this a little bit earlier today, just in preparation. So we just matplotlib and pytube. And so because we want to take a video, the approach that I've taken is use the video, take frames from that video at regular intervals. In this case, I happen to select it at 1 second intervals, and then create embeddings from those individual frames, and then be able to ask queries of that, both in text and using images, okay? So what I've done here is I've connected to YouTube, and on YouTube, we have, under our account, under the SingleStore account, we've actually got a couple of these things. They're called snackables, munchables, very short videos highlighting some sort of key features of the technology. So as you can see, I've put a few comments there. One of those I've uncommented because that's the one I want to use, but you could try it with the others as well. And again, a word of warning, these are fairly short, a couple of minutes maximum. The approach that I've taken here, because we're using CPUs, please don't try and use something, a video that's like a couple of hours long. You will probably be waiting a very long time for it to get processed, all right? There are better ways to do it, right? This is one approach. And with GPU technology and parallelization, you could achieve this faster. There's some limitations that I've mentioned at the end of the notebook, okay? So this is meant to demonstrate that what's possible, but be careful in terms of using it for, very, very large videos. Like I said, it may take quite some time to process. So we're simply connecting to YouTube. We download a video. That's all that's happening here. It saved it here. As you can see, video downloaded successfully. I've picked one of those. And then the next thing to do is actually play it. So this is one of the snackable videos. This is 2 minutes, 22 seconds. I'll just play the beginning of it, okay? And I think I've set the playback speed to 2 times. But let's just give you the first kind of 10 seconds or so of this, all right? Let me just do this.
SingleStore DB offers the world's fastest distributed SQL database used to power modern data-intensive applications. It unifies transactions and analytics in the same engine with high performance to power your modern applications or drive real-time analytics. So you no longer need multiple engines for operational and analytical workloads.
Stop that.
Or have to move data between.
Okay, there we go. So as you can see, it's animated, okay? It doesn't have real photographs or pictures on it, but still, let's test the technology and see how usable it is and see if we can pick out things. So as you can see here, we've got some graphics here, okay? We also have some text that's used as part of this, okay? So definitely we can apply something like CLIP to this. All right. And the next step is just some libraries. Now, we are using the open source version of CLIP. Okay, so you don't need an OpenAI key. All right, which is good news. So it makes life a lot easier. This stuff is free, so it's freely obtainable from GitHub. You can see the link there, github.com/OpenAI clip.git. Okay, so I'm just installing it from there, along with some other stuff, Torch Vision, and this OpenCV Python. Okay, so that's the technology we're going to be using. We import the libraries just below here, and then we load the CLIP model. So what is CLIP? CLIP is contrastive language image pre-training. Okay, model by OpenAI that understands both images and text by associating them in a shared embedding space. So that's the key thing. Okay, this is what allows us to do this kind of multimodal. So it unifies the understanding of images and text by learning to associate them in a shared embedding space through this sort of pre-training. And the thing is, it's pretty awesome, okay? Because you can give it stuff that it hasn't seen before, and it makes a pretty good effort of trying to understand what's actually there. And in this case, for example, it has not been trained on any of the SingleStore videos, neither does it, I suspect, understand anything particularly about SingleStore or MemSQL maybe. But we'll see that it does actually a pretty good job. And then the other technology that we're going to use, because we are dealing with a video, we need some mechanism to be able to extract things out. So we're going to use this vision transformer, VIT. Okay, it's a neural network architecture for computer vision tasks. Processes images as sequences of patches. Okay, patch embedding, positional embedding, transformer encoding layers. VIT extracts features for tasks like image classification and object detection. Again, this is tried and tested technology. It's been around, okay? So it's not something new that we are using there, but we're able to utilize these technologies together. And so what I've done here, I've given the system a bit of information to tell it that I am really working with CPUs. Okay, there isn't a GPU available here currently. And then to load this CLIP model, okay? And you can see there that this is roughly, it's not doing a good representation there, but it's almost 340 megabytes, okay? And just takes a couple of seconds to download. Once I've got it, I've created some helper functions here in order to help with the processing of that. So it's kind of divide and conquer, okay? Split the task down into various stages. So this particular code here, all I'm doing is just extracting frames from that video at 1 second intervals, okay? I chose 1 second intervals because it's kind of easy to deal with, okay? You could choose other ways to do this as well. You could skip some parts of this, maybe you could select a frame every 10 seconds, it just depends. Or maybe choose a shorter interval. But here, we're just finding out some information about the video in terms of the frames per second, and then the sort of frame count. And then we're just dividing the total frames by the frame rate. And then that gives us a good indication of, how many frames there are, and to extract these out. Okay, and then just simply return the total number of frames. Now, you saw that the length of that video was 2 minutes, 22 seconds. This one up above here. There, I think it's still there in the corner. Okay. So the number of frames that it's going to extract based upon the criteria that I've specified, well, it's going to be 60 plus 60 plus 22, 142 frames is what we're going to get, okay, if we are doing this kind of at 1 second intervals. And then the next thing, the next helper function we've got here is simply to take that and generate embeddings for each frame that we have. And again, you can see that we're doing this using this here. Okay, again, just using these libraries, okay, and then doing the encoding here, you can see, okay, to actually deliver me the embeddings that I need, and then just returning those embeddings. So very straightforward, no need to use an LLM in this particular instance. Existing libraries and technologies work absolutely perfectly for that. Once we've done that, we just save these embeddings and image data into a pandas data frame, okay? Okay, so what I've got is 3 bits of information that I've got. I've got the frame number, okay, which I'm quite interested to know. The actual embeddings that have been generated for each frame. And then there's some frame data as well, okay? And the frame data relates to the frame. So it's RGB values, okay? Pixels, information about what's actually stored there. Now, currently, SingleStore cannot handle embedded where you've got vectors that you've got kind of nesting, all right? It can handle standard embeddings. Whether that capability is added in the future, I'm not sure. Maybe there's another way that we can deal with it. I haven't really given it a lot of thought at the moment, simply because I'm not using the frame data for anything right now, okay? But we'll discuss this in a moment. And then here, just simply run the code. So it goes through those functions, those helper functions, does its job, and then it takes a couple of seconds to do that, about 30 seconds or so if we take a look at the time here. Okay, as you can see, I ran this a little bit earlier. So in order to process, this is why I said it's not a good idea. If your video is several hours long, you may be waiting a long time for this to process, okay? And then if we take a look at the actual pandas data frame to see what have we actually got? Well, the 3 things, remember, that we are saving is the frame number, which I quite like to have. Here's the embedding data that is generated. As you can see, the vector embeddings have already been done for us. And there's the frame data. So there you can see there's a kind of a level of nesting. I'll try very hard to show this to you. You can see the level of nesting that there is. And each of these consists of 3 values, okay? So it's the RGB value for a particular pixel. So that's what's being stored there. So currently, there's no problem in terms of storing this data in SingleStore. This data here is going to be a bit more tricky, okay? The nested embeddings SingleStore doesn't currently support. So we need to think of another way of how we would want to store that data if we wanted to put it in a database system. Okay. Then finally down here, just to kind of as a sanity check, to do a bit of checking and see, okay, what have we actually got here in terms of the length of these embeddings? You know, what are the dimensions for the vectors? And it's a pretty standard one, okay? So it's 512, okay? And then 720 for the frame data itself. Remember, the frame data is not something we're going to really work with. So the 512 is what it's used, this thing here, okay? The number of dimensions that we have here for the embedding data. Okay, and then a little bit of code here just to do the similarity. So just below, okay, again, a helper function. And then just below here, we've actually got a query that we enter in text. What this does then is it converts the query to an appropriate format that we can use. It needs to be represented as a vector as well. And then we use that vector against the data that we've actually stored in the pandas data frame for that embedding data. And we're using dot product, okay? That's the mechanism here. So again, very straightforward. Standard techniques, well understood. Nothing particularly unique so far, okay? And then finally, or what we can do then is to say, okay, you've done the comparison. The text that I've entered in here, which was what I was interested in, was ultra-fast ingestion. That was my query, okay? And so it's looked for that pattern within the 142 frames that have been saved, and then it's done the similarity search using dot product, and then I've asked it, return me the top 5 answers in terms of the best that you've found, and here's given me a list. You can see, and this is why I said the frame number was kind of useful. It's shown me the frame number and the value of the similarity. Okay, so the top answer was 39. Frame number 39, followed by 40, 43, 37, 42. And then just below here, I just use matplotlib to plot and show me the actual frame. So if we look at that, you can see it's done a pretty good job, okay? So remember, ultra-fast ingestion was the string that I was looking for. And so it's identified that in frame 39, in frame 40, in frame 43 there. This one is a bit of an odd one. I can't figure out where this has come from. So further investigation there, but it's got the last one right here as well, 42. So it's done a pretty good job there. So that's the kind of the textual part of it. How about if we wanted to do the image processing? Very similar here. What we would simply need to do is to have something to compare against, take an image, find something appropriate, and then compare that against the embeddings that we've already created. Okay, remember that is not something we have to repeat. The initial work that we put in to separate out the frames, create the embeddings, that's all stored for us. So what I've done here, again, is taken a couple of images. These are the three kind of images that represent the three videos as they are on YouTube. And you can see just below here, I've rendered that the one that I want to use as a query, the one that I want to use to compare against what I already have here. Okay, so what makes SingleStore DB unique? And then similar sort of process here. Okay, I've got some helper code to convert that into a suitable format to compare it. And then again, I've shown the top 5 best matches here as far as the image is concerned. Remember, this is purely the image now, not the text. And again, it's given me an output to tell me which of these have come out. So frame number 7 has come out the top. And then we can, again, use matplotlib to plot these to show us. So again, you can see it's done a pretty good job there. Frame number 7. Frame 9 is a bit odd there. So again, further investigation. But here you can see that the text hasn't quite made it, but it's got the frame itself, simply because I think that was in the process of rendering and hadn't quite completed. So it's like a snapshot. We see it as a sort of point in time before it was fully rendered with all the text. So that one is popped up as well. And then that one, again, you can see the image, definitely the unicorn on the right-hand side. It's got that right. Okay, that one's pretty good as well. So overall, that's not bad. That's quite pleasing in terms of the result. And then the final thing to do is to say, well, okay, we've got the text, we've got the image. How about if we try to do a combined query? And so this is actually very easy, because the way this is done using this technique is by simply doing this pairwise, adding the two parts and then dividing by the number of representations that we have. So the combined query takes the result of the text plus the image, okay, and then divides by 2, okay, because we've got 2 different representations here. And then again, we can plot and say, show me the top 5 best matches. So that one comes out pretty good. And then again, that one, you can see it was in the middle of kind of rendering that one. Here you can see probably the text was the deciding factor in that one. Certainly the image doesn't seem to have come out. I mean, you can see the disk there appears as part of that. And then this one, again, that kind of makes sense. So overall, this is very straightforward. Helper functions do a lot of the work for you. All right. It is one way that you can manage videos. I'm not saying it's necessarily the best way, but it's certainly a technique that you can utilize. And as you can see, at small scale, this works really well with CPUs. There are some limitations, okay, as I said, at the bottom of the notebook. And so the next thing to do is to say, well, okay, we don't want this to be just something for now, for the moment. What if we wanted to save these embeddings that we've generated as part of this effort into a database system? Well, we can do that. And so all I've simply done here is just prepared the pandas data frame. I've dropped a couple of the columns here because we don't need those anymore. We are really interested in storing the embedding data and the frame data. And again, a helper function there just to make sure it removes any unnecessary characters. Strangely enough, you've got some carriage returns and some other weird things that have been generated in the embedding data. I can't quite understand why, but but it may be, a technology-specific issue. I'm not sure. But anyway, finally, we've got the frame here, the pandas data frame in a format that is ready and suitable for writing into SingleStore. And then just below here, we create the database. So if you're using the free tier, you do not need to do this step, okay? Because the database is already created for you. If you're using the dedicated, configuring your own sort of resources, you will need this. So simply create a database, and then we just make sure here that we select it from above here, okay? So in this particular case, if we have a look, it would be this one, and you'd make sure you'd select the video DB, which is the one. I mean, feel free to change the name if you wish above. And then here, I'm creating a table, okay? So it's just got 3 rows to match what we have in the pandas data frame. A frame number, it's useful. The embedding data itself, okay, the vectors. And you can see here, we've specified the number of dimensions here. It's 512, okay, to match what we discovered earlier. And then the frame data itself, because it's embedding, it's nested. As useful as it is, I'd like to keep it, but I have to save it as text currently. But the information is there. I need to give that some thought to see if there's a better way to do that. Maybe as JSON or something like that, perhaps. But for now, that's fine. And then we simply write the pandas data frame to the database. It tells me it's 142 rows are written. Just as a sanity check, we read the data back, 1 row, just to check that it's actually gone in. And in fact, and we just control the display there a little bit, so it's not overwhelming the notebook. So that all looks good. And here is where we're creating this approximate nearest neighbor index, okay? So this tells the system that we want to use dot product naturally, okay, because that is the mechanism that we used earlier, okay? So we stick to the same approach because we're going to do a comparison now. And it's going to do the auto indexing for us. All right. And then here, first thing we can do, I just noticed a typo here. Sorry about that. I will fix that and upload this to dot product. Get it right, Chowdhury. So there we go. So the first thing we can do is to say, okay, and here's a question for you, a quiz. What is dot product without an ANN index? If we do not use ANN, what are we using? Right? Answers on a postcard, okay? Simple answer, it's KNN, it's brute force. If we're not using the approximate nearest neighbor index, it's gonna do a KNN. Essentially, it's gonna work through and do that and do the similarity search for us, okay? So we see the results here. Okay, frame number and the similarity, the data. And if we compare this to the results that we output for the combined, it's exactly the same. Frame number 7, 5, 13, 16, 6, and the similarity scores are the same as well. And now just below here, we're actually making use of the actual index itself, the ANN index. Remember, this is going to be very, very useful at scale. So if we had millions, tens of millions, billions of data points, this is going to be able to give us results across that data set very, very fast. We would lose accuracy, though. That's the key thing. Now, in this particular case, because it's very small, you can see that in terms of what we get without using the index, compare it to what we get with using the index, the answer is the same, okay? There's no loss in that information there. So it's exactly the same. And then just below here is just another way of retrieving the, performing that query again. And again, you can see we can just check the result that's returned. And again, we could match this and compare this against the pandas data frame that we had, and you'll see that the results are the same. So in this particular case, what we've done, why use a database system? Simply for memory, okay? Long-term storage. We've gone through the effort of creating these embeddings. We've identified, in this particular case, 1 second frames that we want to store, along with our RGB values in terms of the frame data. The database will allow us to store that long-term. We can query that now. We don't have to regenerate everything. And we could do these kind of queries on this. And if we have much larger quantities of data stored, as you can see, we can perform these queries much, much faster, simply because of the way that the ANN index works. Okay, and then, as I mentioned before a few times, I've hinted at the fact that there are some limitations to this approach, okay? By no means perfect. So frame extraction is at fixed intervals based on the frame rate. Perhaps there could be a better way to do this. You know, we might miss some important information, or we may be creating some redundancy. You saw, I think, some elements of that in the output that we had, that I showed you a little bit earlier. The embedding generation is, again, it's inefficient for large videos. It's done sequentially, okay? And therefore, maybe using some parallelization or batching or something like that might be a lot better to improve the performance, particularly once your videos and, you know, the kind of file sizes get much, much larger. And then similarity calculation, again, we are doing this sequentially. Again, perhaps thinking about parallelization to speed up the computation, especially for large videos with many frames, right? So there's improvements that we can make along the way there. All right, whilst we are here, let me just fix this, okay? And don't like to see, there we go. Okay, there we go. So let me just switch back to the video, and I think we've got time for a couple of questions. So again, my favorite quote, so, any sufficiently advanced technology is indistinguishable from magic. So there you can see quite a bit of magic there. Very easy though. Yeah, you can all become magicians. No OpenAI key required there. Uses standard libraries, standard techniques, and you know, it's a very straightforward and easy way to be able to generate these interesting kind of queries that we can ask, whether it's textual or it's based on an image, using this CLIP technology. Okay, thank you. Matt, time for some questions.
Yeah,
sorry, I couldn't finish earlier. I know we've always got
do one or two questions before I announce the raffle winner. One is from Charles here. What would we need to do differently to use Hamming distance for faster response?
Sorry, repeat that, please, Matt.
What would we need to do to use Hamming distance for faster response?
Oh, Hamming distance, good question there. I've never come across that for this type of problem. I need to look into it. Did you say Charles asked the question?
Yeah.
Okay, so we can let me investigate that and do a bit of research. It's usually for this type of problem, for the similarity searches, it either dot product, Euclidean distance, cosine similarity. Those tend to be the common ones. SingleStore supports dot product and Euclidean distance out of the box. You can code the cosine similarity as well. You can create your own UDF function to do that. That's very easy to do. I wrote an article about that not so long ago. Anything beyond that, so Hamming distance, for example, is something that I've not seen used, but again, I'll investigate that and research it. Take a look into that. Great question. Thank you for that.
Awesome. I see maybe one or two more here. One from Jaspel. Can we use grayscale frames instead of the colored frames? Does that improve your latency?
Grayscale, that's again, great question. I didn't give that too much thought. What was on the top of my mind was to try to find something fairly small in terms of processing so that when you try it, you don't have to wait a long time to do it. I'm sure if you use grayscale, because I mean, even with grayscale, there's a range, isn't there? You know, with colors, we are dealing, and I'm not sure, and this must be in the sort of millions of colors, but grayscale can potentially also span a wide range as well, maybe in the thousands, possibly. But you could, you know, if you've got something that is much more restricted, smaller in terms of the actual grayscale values, yeah, I'm sure that might be a lot faster in terms of processing. But a better way to do it would be to parallelize it, use GPU technology, which I think is coming to our platform anyway. So that's something that might really help.
Awesome. All right, I am going to, there's a lot of folks that have given a lot of compliments throughout Akmal. We can follow up with the rest via email. Want to quickly remind everyone that we've got several great webinar sessions coming up over the next few days. Some of them are Akmal himself. So I've just put those in the chat. Monday is fine tuning.
Yeah.
Tuesday is Apache Spark and OpenAI for personalized banking. Wednesday, accelerate MongoDB apps. We also got that one on Kafka next week. So a very full schedule. Check those links. They're in the chat. Hopefully we will see you there. The announcement you've been waiting for. Today's raffle winner goes to Naresh Dulam, VP of Engineering at JP Morgan Chase in Texas.
Congratulations.
Congrats. Thank you for joining. If that's not you, don't give up. We're going to announce one more AirPods winner or Meta Ray-Bans winner, your choice, by the end of the day, to someone who has tried out Akmal's demo. So I'm going to put that in the chat one more time in terms of the sign-up link. Try it out, sign up. We'll also put that in your email. You're going to get the recording. You'll get the GitHub link, related resources. Try it out. Hopefully you'll be our next winner. And thank you, Akmal. Amazing session as usual. And thank you to our audience for joining us. See you next time.
Thank you.
Bye-bye.